Alright, so do you have any question, guys? Alright, so do you have any question? So fine.
Sir, regarding what?
Regarding any issue? No question. Alright, so
Sir, tomorrow is our lab class, right, sir?
so did you get any announcement from lab Slack channel?
No, sir.
No, sir.
So you will get the information from regarding that lab. You will get that from the lab Slack channel, because I'm not responsible for your lab. And there are different faculties, they will run this lab, so they will give you the information regarding the lab. So you should ask any question related to the lab over there.
Okay, sir. Thank you, sir.
Yes, Rafid Khan. Rafid, I cannot hear you.
Your voice is breaking, Rafid.
Why is it like a robot?
Exactly, it's a different language. We
Yeah, you
cannot
sound like a
understand.
robot.
We cannot understand that language, right? The different signal.
Yes,
probably.
it's like signal or electrical pulses or something. Yes, sir.
All right, so
Like the boards
so
in
my box isn't updated yet. Why? Why it's not update? Update means, what do you mean by update? Will it update?
Sorry,
after?
I think he's trying to say there is no new content for week 2.
Oh, that's thing. Oh yeah, yes, because still we are talking about right now a new week isn't available. That's true, because still we are talking about the vector, so that's why we do not release that topics. Unless we cannot finish, then we will be not release those topics. After finishing that vector, we are going to probably the next Thursday or by Wednesday they will release that second week topics, because still we are talking about the vector right now, right? All right, fine. So let's start today's topics basically. So can you see my screen?
No, sir. No,
No, sir.
No, sir.
All right, I hope you can see it right now.
Yes, sir.
Yes, sir. We can see.
Yes, sir.
So this is a case, you have a coordinate system x and y. This is negative x-axis. This is, say the two vector actually we place in that way. So one vector is this is say the vector A, which has 100 meter. Another vector is the B, which has 200 meter, and it's create an angle 45 degree. Now my intention to find out the resultant of these two vectors. Now can anyone make a guess what would be the resultant direction of the vector, but just only the case. I'm not expecting that you will find out precisely, but can you make a guess that what will be the resultant direction of this some of these
Y-axis बराबर.
Towards the y-axis
towards
or
the y-axis,
upward?
upward direction? All right, so I should say that's a very good case. All right, so I can copy, say that if I make a copy of this vector, if I make a copy, then resultant vector will be towards that direction, right? Which is not exactly towards that, basically that y direction. It will create, it will create some angle in the y-axis. You can find out, because this is actually that over here they are head to tail connection, over here they are in head to tail connection. Those resultant vector would be towards in that direction. So that is actually that graphical representation giving me that one, but I will find out that thing in terms of unit vector. First I will express that vector A. I can write down the vector A, actually that 100i. This is the vector A. Now the vector B, we can write vector B. I'm going to take the projection of that vector or the component. I will use that idea to find out the vector B. I'll write B cos 45 I hat, which would be the negative over here, plus B sine 45 z hat, right? Do you understand why or how did I write down this equation? B cos
Yes, sir.
45 I hat plus B
Yes,
sine
sir.
45 j hat. So it's basically the component I write in that, because if you take the projection of B, you will find out this one, which is B cos 45. If I multiply with that, I'll find out I hat is the negative direction, and this is V sine 45, which is that direction, positive y direction. Then this is would be another vector, which is y, and this is would be one vector, which is that. Now this is actually head to tail connection over here. So minus B cos 45 I hat plus B sine 45 j hat would be resultant vector B. If you plug in the value of B, you will find out that magnitude of that vector would be minus 141 I hat.
So the negative before the B minus before the B cos 45 I cap is due to the component, to the second quadrant.
Yeah,
for
due
that
to the in the
reason?
negative x-axis, so that's why the minus sign.
Okay. So
And this one will be also 141 j hat, right? This is actually that vector B I represent in that way. Now if I add them right now to find out the resultant vector, say that A plus B would be 100 I hat minus 141 I hat plus 141 j hat. then if you add, you will find out the resultant of this one would be 41 I hat plus 141 j hat. This is actually the resultant vector of this one. And if I find out that magnitude of this vector a plus b, I hope you know how to find out that magnitude, which would be basically root over minus 41 square plus 141 square. That will give you actually 147 meter. Right. So this is the magnitude. I know you how to find out that one. Now if you find out the angle, that should be tan inverse y 141 divided by minus 41, which will give you actually that minus 74 degree. Now this theta is minus 74 degree is from where? If you say that minus 74 degree, then I will assume that it is moving to the clockwise direction, that one. If you just write down that minus 74 degree, that would be because it is moving to the clockwise direction. When you use that formula theta equal to tan inverse y by x, it always give you from nearest x to y. It will be always from nearest x to y. Theta equal to tan inverse y by x is always give nearest x to y. This nearest x to y means since if you only say that the minus 74 degree, which is would be from negative x-axis, because you find out that component of that vector actually x component is negative, right, which is minus 41, and y component is positive, which is 141. So that's mean this is my x component and this is my y component in towards that direction. So definitely the resultant vector will be in between two, and it will be closest to the y component because that one is bigger. So this is x, y, this is minus x, this is minus y. And this angle y by x going to be give that one, which is minus 74 degree. And minus this sign is minus, basically this is actually the clockwise direction, and it is from nearest x means is giving me from negative x-axis to y direction, because that angle is closest to the y for this resultant vector. So but if you say only the minus 74, then I will assume from it will be in the fourth quadrant, but it is actually in the second quadrant. You can say negative 74 degree from negative x-axis, or you can write 74 degree from negative x-axis clockwise, or otherwise you can say this angle, which is actually would be how much, 106 degree. My God, 106 degree. That is the right answer over here. So that's mean you have to precisely say find the angle, otherwise it would be difficult to predict the trajectory of a particle. When we are going to talk about the motion in 1D and the 2D, I have to find out the resultant direction. Unless I cannot find out that resultant direction properly, then it would be difficult for us to follow the trajectory of that particle. So why I'm saying that, because when you're using tan theta equal to tan inverse y by x, this formula always give you from nearest x-axis to y-axis, and we find the angle from always positive x-axis to counterclockwise is positive, and the clockwise angle would be negative. Now say for example, if I say a vector, say that a vector has a in a form is a two-dimensional case, 2y plus 2j, what would be its angle? Theta.
So 45 degree.
45 degree. That's going to be fine. What about if I say A is minus 2I hat, sorry, into minus 2Z hat, what would be that theta?
Will it not be 45?
45.
This is the 45 degree, yeah. So definitely that formula
225.
225
Yes, sir. 225.
to a tan inverse minus 2 divided by minus 2, that definitely going to be that tan inverse 1, which would be theta would be 45. That's right, because if you plug in that value into the calculator is going to be that 45 degree, because it's basically the 1 ratio is 1. Calculator is right, but it is not actually that 45. 45 is basically from negative x-axis clockwise, because this is your x component and this is actually your y component, right? Then resultant would be in between these two. That is actually the resultant vector. And this angle, that would be the 45 over here from nearest x to that resultant vector or y direction. This is counting from negative x-axis 45 degree. If you say only 45, it should be in that first quadrant, but it is actually in the third quadrant. I have to say in way from negative x-axis is 45 because it's positive counterclockwise, or you can say 45 plus 180 degree, which is 225 degree, right? So that's why calculator not always give you that accurate result. You have to closely observe the component of a vector, which to direction it is, then you can find out that one.
Sir,
Yeah,
cannot we use the formula that we learned in college, as in for magnitude, it's root over a square plus b square plus twice ab cos the angles between the given vectors?
to find out what
Magnitude?
magnitude means, theta angle,
No, sir.
vector magnitude.
A resultant.
Asking about the resultant of the two vectors.
Resultant vector. She's asking about the resultant vector. sir.
Yeah, you can do that, but don't do in that way actually, because that scenario is not going to be basically work in every situation. That's a formula, I know that come from, this is actually that basic thing I'm going to talk about. That's one more basically the special case. Don't do in that way. That formula is not going to be the work in every situation.
Okay, thank you.
So say I have another case. Say if I write down, this is actually that 2I hat plus 2j hat. What would be that in that case? Angle theta would be minus 45, right? Because 2y minus 2, that's ratio would be the minus, or so angle would be negative 45. So negative 45 means from this negative x-axis clockwise, because this is your x-axis is negative and y-axis is positive. So this is would be your resultant vector. Then this is actually that minus 45 degree. Then in that case you have to say that from negative x-axis minus 45 degree, or you have to say 135 degree, right? Because this angle 180 degree minus 45, this is actually 135, which would be that angle, right?
Yes, sir.
All right, so what about the issue? Say if I say 2I hat minus 2j hat, in that case probably you will find theta equal to tan inverse minus 2 divided by 2 theta. In that case would be basically minus 45 again. Ratio is minus 1. Now this minus 45 is correct. If I say only minus 45, then I'm going to write this one, because this minus 45 is going to give me that angle. This is my x component, which is positive. This is my y component, which is positive, and this is my resultant vector, this one, and that should be that minus 45, which is clockwise this angle. This is right. You can say, or you can say this one, which is minus 45, or you can write 315 degree. That's how actually you can find out the resultant direction of a vector.
Sir, how is it 315?
Because this total angle is 360 degree, right?
Yes.
Then I subtract 45 from that 360 degree.
Oh, okay.
So that's how actually you can
I got it now.
That's how actually you can find
Sir,
out.
if I add 240 degree,
Yeah, that's also 240. Why?
180.
270.
Oh, 270. Sorry.
Yeah, then it's going to be there. Yeah, 270 degree plus 45. The same thing.
Okay. Sir.
But whatever the issue actually you raise, but anyway you can find out the way you like. But my point is you have to find out the angle precisely. Otherwise, it would be difficult for you to predict that trajectory of a particle in the case when we are going to talk about 1D, 2D or 3D motion actually. It is necessary to find out the angle properly. Otherwise, it would be difficult to predict the trajectory of a particle. Let's talk about the multiplication. Multiplication of vectors. Say I have two vector A I express in Cartesian coordinate system ax I hat plus ay z hat plus az k hat. Vector B is bx I hat plus by z hat plus bz k hat. Then there are two ways we can find out that multiplication of this vector. One we know, which is dot product. We say the dot product, right? Or scalar product, or sometimes we say that inner product. So this dot product could be find out the two method actually. One method we can write, say that a dot b actually ax bx plus ay by plus az bz, right? Do you know this formula, how it's come, or should I show that one? It's nothing. It's basically that product you the vector you write side by side, which is ax I hat plus ay z hat plus az k hat. This vector dot vector b bx I hat plus by z hat plus bz k hat. What I'm going to do over here, basically I'm going to multiply with that quantity with rest of the vector coefficient over here, right? So ax,
Sir,
yeah,
sir, on the first line, shouldn't it be ax bx I on outside of the bracket.
This one, this, are you talking about that one?
Yes, sir. Yes, sir.
No, no, no. This is the final formula.
Sir, the I cap, J cap.
That, that's a very good point. Thank you very much. So if I write I cap, j cap, k cap, will be a vector or will it be a scalar?
It will be vector.
Vector, vector.
But a dot b is a vector product or a scalar product?
Scalar.
Scalar
Then
product.
why I use the I cap,
Scalar
j
product.
cap, k cap over here?
Oh, sir, now I got it.
Yeah, don't make
Sir,
that
I don't
mistake.
know your class, sir.
Yeah.
Sir, I'm kidding. I said I don't know your class, maybe.
So why I write down this? Because this is a dot product, and how it's become. That's the thing I'm showing you over here. Look at this. Yes, this question is there. Sometime student write a dot b. Actually, they write I cap over here, j cap over here, and k cap over here. Why? It's a scalar quantity. There will be no vector over here. It's a dot product. If you write down the
So
I, j, k over there,
sir,
which is
the
actually,
I and I will multiply in 1 and
yeah, I'm showing you that one right now. I'm showing
okay,
you
sir.
that one. So look at this. I'm going to multiply this axi with the rest of the quantity of this quantity. So that's why I write the ix ax bx I dot I plus ax ay I dot j plus ax bz I dot k, and rest of on so on, right? You have to multiply with that ayj with the bx by bzk, and azk would be rest of the thing bx by bzk. I do not write that thing. If I show you, you can understand, I hope. Then I know for dot product, for properties of the union vector, similar identity will be survived. So that's mean this is I dot I is going to be the 1, but this I dot j is going to be the 0, and j dot k is also going to be the 0, right? Then I will find out, finally I will find out basically ax bx from that product, and rest of the thing I will find out ay by plus az bz, right? I'll find out these things. So this is should be actually resultant product. So that's the one I write down over here. So that's how actually is came over here. So how I'm going to find out that dot product. This is one procedure. If you know that two factor, then you can use this formula to find out the dot product. And second one we use, which is actually a dot b, it would be ab cosine theta, which is very useful and very handy formula. So that's thing actually, this is say that vector a, this is the vector b, and this is the angle, is the theta. Then we can write down AB cosine theta basically. I'm not going to show that formula. It could be also the proof A dot B would be AB cosine theta. If you want, you can find out this proof in the online actually, or the YouTube, you can search that one. If I want to do that, it will take some time, so I cannot cover my lecture in that case. But my point is, what is B cosine theta over here? B cosine theta basically the projection of vector B along the direction vector A, which is this one, B cos theta, or we can write B into A cos theta, which is that one. I can write this thing would be that A cos theta, right? So that's how actually we can write down this dot product. One is, and this formula A dot B, AB cosine theta, is always applicable. You can find out the angle between the two vectors using this formula. This is very handy formula and very useful formula. We'll use always this thing. I'll show you. But before that, since this dot product is basically the scalar quantity, then we can say this could be greater than 0, it could be equal to the 0, and it could be also the less than 0, which means the negative. It would be greater than 0 if theta is greater than 0 and less than 90. It will be equal to the 0 if theta is 90. It could be less than 0 if theta is greater than pi by 2 and less than 3 pi by 2. That's with the properties of this positive, negative of this one. There are some characteristics. Say a dot b, actually we can write a dot b would be basically b dot a, because it's a scalar product basically. So that's why if you write 3.5 or 5.3, that's going to be the same result, which is the 15, right? That's why you say that dot product is basically that symmetric. There is, we can write one thing, a dot b plus c, which is a dot b plus a dot c. This is called actually the distributive properties of this one. So I can also write down this thing in that way: b dot a plus c dot a is going to be the same thing. There will be no change, right, by the symmetric properties. Or we can write m into a dot n into b, which is m into n into a dot b, where m and n basically the real number set. We can write in that way. So these are the properties of this unit dot product of this vector. Now let's think about another case. I'm going to do a problem, or I'm going to show a application of this dot product. Say this is a now say this is a cube. Actually I have say this is a one diagonal into that plane. Say this is a vector A I express, and this is another diagonal into yz plane. This is the vector B. Now I want to know what is the angle between these two diagonal, this theta. Do you understand my question?
90.
90. Right. Theta would be what over here? Any more guess? What could be that angle? Or all of you agree with her?
So with her because it's a perpendicular.
Alright, let's check that. Fine. So say if I want to reach that point, say I consider this cube has the one side is 1 unit, or the edge length actually the 1. Then if I want to find out the coordinate of this point, it would be basically 1, 0, 1. Can I write? Is that okay? The coordinate of that point would be 1, 0, 1.
Yes, sir. Right.
By the same analogy, we can write for B is 0, 1 and 1.
Yes, sir.
So I'm confused about this one. 0, 1 and 1 and as in?
So I find out that coordinate of that point, because if I want to reach that point, I have to move, I don't have to move to the x-axis. It is basically in the xz plane, sorry, yz plane, in that plane. Do you understand?
So what about the sir, the A point is y, it's because it's in the exact plane, that's why it's, the y-axis
0, yes,
is
exactly.
0.
Yeah, because that is the diagonal of this face and B is the diagonal of that face. So if you are in a room, you have two walls, you can consider two diagonal into that wall which are perpendicular to each other. Then I'm trying to find out that angle between that two diagonal vector. Did you get my point right now?
So basically there are two angles between the A and in the case of 2 theta, the angle between the z plane and the A vector and the z plane with the B vector.
No.
Isn't the
No. I want to. Why you think the 2 theta? I'm going to find out only the angle between these two vectors.
Yes, sir. But these two vectors are on the planes of the axis, on the planes, so that's why the theta between them is like plane wise. Otherwise, it would be like on the how it be possible
on the
like the angle between the z the theta is made of with the two angles, like the a cap and the z axis and the v axis. These two angles I think made as like formed within the theta.
No. Then you are talking about in terms of plane actually. In terms of plane, you are talking about. You are saying that. Let me draw for you. You are saying at this angle, which is created with that one, right? With that z-axis, A is created
Yes,
the
sir.
z-axis, and
Yes, sir.
B is also created the z-axis.
Yes, sir. Since these are the on the
No. That's not the angle between the A and B. That's the angle between vector A and the z-axis and vector B with the z-axis. That doesn't mean that is the angle between the vector A and B. That's not. Which is 90? Which is 90?
The origin of the z-axis.
Yeah.
So the z-axis, the point of the origin is situated in the theta at the intersection of the theta or other way.
No.
Sir,
Theta,
simply, sir, would you make us understand the coordinates? Then it would be easier.
yeah, coordinate means this is your origin. This is your x-axis. This is your y-axis. This is your z-axis. I'm thinking about the three-dimensional case actually. If you are in a room, think in that way. You have a box, or you consider your room is a square or a cube. Consider as a cube. Basically, we are dealing with the cube. Your room is a cube. Now you have the two walls which is perpendicular to each other. Now you draw from your origin one diagonal towards that one corner, and in another wall you also consider a vector in diagonal. Now my job to find out the angle between these two diagonal vectors. That's the thing I'm doing over here. To doing that, I find out that coordinate, this one. Do you have any confusion over here? This coordinate, how do you find out? Because when you find out that coordinate or vector, I don't have to move in the y-axis because that diagonal actually in the xz plane.
I understood. I get it about the coordinates.
All right, that's great. Now I'll write down the vector A. In that case, it would be 1 I hat plus 0 z hat plus 1 k hat. Can you write down that vector A, which is ultimately?
Sir, I'm not sure যে এখানে এটা লেখা যাবে কারণ এটা তো আমরা জাস্ট ওই পয়েন্টার যে ওইটার মানে এই বের করছি যে কোঅর্ডিনেটটা, কিন্তু ওইটা কি এর জন্য প্রযোজ্য?
Of course, why not? Look at this. So do you have any idea of the component of a vector?
Yes, sir.
So this is your vector, right? If you take the projection, this should be that one, which is actually that A cosine theta, and this would be your A sine theta, right? So this is the vector A. This is the create angle over here. Then if I write A cosine theta I hat, this one, plus A sine theta j hat, this vector, I am going to write down this vector would be A cos theta I hat plus A sine theta j hat. Can I write down this one?
Yes, sir.
Then why not this one? I know this magnitude, which is 1. I multiply that one by I hat, plus this one is also that 1. I multiply by that one into z hat. I am not moving to the y direction, so that's why I write down this is 0. Then I plus j is definitely going to the vector A. Please guys, to calm my class, you have to clear the previous idea, otherwise you will fail the difficulties. I said it again. Before coming my class, you have to go through my previous lecture. So
Sir, is theta 60 degree?
Theta is 60 degree.
Yes.
Definitely it's 60 degree. In that case, I can write down this magnitude is basically the 2, right? Same way, I can write down the vector B actually would be j hat plus k hat, because it's a 0 1 1. Then I can say that magnitude of vector B would be also the square root 2, right? Now if I write A dot B would be AB cosine theta, that formula I'm going to write. I write down AV vector, which is I plus K. Then I plug in the vector B, J plus K, which is magnitude root 2 cos theta. Then I can say I'll multiply with this quantity, right? What would be that value? I dot j is 0, or I should write this one. So I dot j plus I dot k, I multiply with I the rest of this quantity, then I write k dot j plus k dot k, and root 2 would be basically the 2. I'll find out the cos theta. This I dot j is 0, j dot k is 0, k dot j is 0, I dot I basically the 1. Then I find out cos theta would be the half, which would be basically cos 60 degree. Definitely the angle of these two diagonal vector is going to be the 60 degree. Although the planar is 90 degree, it doesn't mean that the angle between these two diagonal vector is going to be 60 degree. Where? Because they are in the different direction. They are not in the parallel of these two planes. Did you get my point? Is there any question over here?
No, sir.
All right, let's think about another case actually. Say I have a vector, like say the vector A is 11 I hat plus 5 j hat minus 7 k hat. This is the vector A, right? Now I want to find out that angle between that vector and the z axis. So if I draw that vector, so this is my x-axis, this is my y-axis, it's a three-dimensional case. I'm going to find out, and say this is the z-axis over here. Then my vector was I write over here, so it would be easier for me. 11 I hat, only I choose any arbitrary vector actually, z hat minus 7 k hat. The why will be that location of that vector actually? So I have to move the 11 unit towards the positive x direction. Say this is actually the 11 unit. I take the arbitrary. Then the 5 unit, say that this is it be over here, and then the negative 7 unit. So that's when I have to go to the downward direction, right? So this is to be the downward direction. Say this one actually, that this one. Now if I draw that vector, this is the vector A. I just draw a arbitrary vector. Now I am going to find out this angle, this one, vector angle with that positive z axis. My target is that one. Now from figure, is it clear that that angle would be greater than 90 degree? Can you understand this thing over here? Because this vector is towards the negative y direction, which is basically below the xy plane. Below the xy plane, right?
Yes, sir.
So I'm going to find out that one actually. So since I'm going to use that formula, a dot b actually ab cosine theta, right? Right?
Yes, sir.
Then I have a vector which is A, is the vector A, and towards that y direction or the z direction I have another vector which is unit vector is the k. I'll write A dot k would be, because I know that the magnitude of that unit vector is basically the 1. I'll write down the magnitude of A. So magnitude of A vector actually it would be root over 1, what could be that? Can you do me the calculation for that one? Is going to be 11 square. Let me do that calculation. So 11 square
195.
195 plus 5 square
sir.
plus 7 square,
Sir,
which, yeah, it's a 195 exactly.
it's a 13.96.
I write down in that font. All right, it should be 13.96. So 13.96 the magnitude. So 13.96. That's great. And I know the magnitude of k is basically that 1, right? So I'll write in that case. And what is if I write magnitude of A, magnitude of k into cosine theta. Now what is A dot k?
Minus 7.
It's a minus
Minus
7,
7.
right? Because if you multiply with vector k hat over here, is a I dot k is 0, z dot k is 0, k dot k is basically that minus 1. It will give me minus 7. All right. Then I can write is a minus 7 equal to root over 195 into 1 into cos theta. Then I can find out that theta would be cos inverse minus 7 divided by root over 195, right? Then I will find out that theta, this would be my let me do that thing.
120. Sir,
It's a 120. Exactly.
120.094.
Yeah, it's a 120.09. That is the angle. That's how actually we can find out the angle with any vector with any axis. I can do it with the positive x-axis, I can do it the positive y-axis, or I can do it with that negative y-axis or negative z-axis, as well as negative x-axis also, using that formula. So that's why I'm saying that this formula is a very useful formula. We can find out the angle with any vector or any direction I want. You can find out that resultant direction using that formula. So that's why I say that it would be easier for us to find out that angle between two any vector using that formula. Alright, let's talk about the vector product. Vector product or cross product, or sometimes you say that outer product. Cross product, we can find out the two way also. One is the determinate process, that is we should write A cross B actually I, J and K. I'm writing the coefficient of vector A and B, which is AX, AY, AZ, BX, BY, BZ. Right, then to solve this one, basically we have to use determinant procedure, which is A cross B. I'll write, if I write down the equation, I'll write, let me write down first, then I will explain. AY BZ minus AZ BY plus J hat into AZ BX minus AX BZ plus K hat AX BY minus AY BX. Now how did I write down? I know there will be a issue for a minus sign over here, plus minus sign over here. So if you use the minus sign, in that case this one is going to be the reverse. It would be AX BZ minus AZ BX. So we can write down this one is basically I know sometimes you guys make a mistake to write down that formula. To overcome that confusion, I write in a this way. So if I write x, y and z component, when I write this zx component, then I will start ay vz minus az by, because counterclockwise is positive and the clockwise is negative. So that's why I write down, when I'm taking the x component, I will start from the y, ay bz minus az by. Second one, when I'm talking about the y component, I'll write az bx minus ax bz. I write az bx minus ax bz. When you're talking about the z component, we'll write ax by minus ay bx. That's how actually you can carry this information in your head. because sometimes you guys make a mistake to write down that formula, which is unfair. I think this level, do not try to make if you write in a wrong way, your calculation would be the wrong. It shouldn't be fair to make a mistake to write down that formula over here. And there is another way we can find out that cross product, which is we write a cross b, actually ab sin theta eta hat, where remember this eta hat will be always perpendicular to vector a and b. This is the vector a, this is the vector b, this is the angle, the theta, and remember this eta hat will be always perpendicular to this vector. If you write sorry, it's a plus direction. If you choose this a plus, then this would be that minus eta hat. If you write a cross b, that's going to be that eta hat. Then b cross a is going to be the minus eta hat. Right. So that one actually we can find out using the right hand rule. Actually, what that right hand rule, you have to use, say that you have to put your forefinger or the index finger towards the first vector, and you will rotate rest of the finger from first vector to the second vector. In that case your thumb would be upward direction, so that's why a cross b will be upward. But if you do in reverse way, if you put in, this is actually index finger, if you keep in that way, then if you rotate from b to a, that should be towards you. In that case your thumb would be the downward direction. That's why b cross a would be the minus eta hat, and that's why we can say that a cross b not equal to b not equal to b cross a. You can write down a cross b equal to b cross a. In that case a cross b equal to b cross a, I have to use the minus sign over here, b cross a. That's the case. So that's why we sometimes say that the cross product is anti-symmetric. It's not symmetric. It's not symmetric. And remember this one, when you're using this one, this eta hat will be always perpendicular on both two vector a and b. It doesn't require that a and b would be perpendicular to each other. Sometimes they could be and sometimes not. But this a cross b is always perpendicular. This eta hat would be always perpendicular to each other. So that's how actually we can write this one. And since this magnitude of this cross product would be also, say if I write a cross b is greater than 0, it could be equal to 0, and it could be also less than 0. It will be greater than 0 if theta is greater than 0 and less than pi. It would be equal to the 0 if theta actually that n pi, where n equal to 0, 1, 2, 3. It would be less than 0 or the negative if theta is greater than pi and less than twice pi. Then we can write down in that way. There are some properties actually we say that is we can write in another way, which is a cross b is not equal to b cross a, because it's a anti-symmetric, it's not symmetric. We can write a cross b only if we use the minus sign b cross a. Second property is a cross B plus C would be A cross B plus A cross C actually, which is actually the distributive properties of that one. I cannot write down over here B cross A. If I want to write, I have to minus sign over here. B cross A minus C cross A, if I want to write down in that way. And the third one actually I should talk about if I write M cross A cross N cross B, actually Mn A cross B, where M and N actually they're the real number set. Is a real number set. That's the properties of these. Now let's talk about the triple product, which is useful for the physical significance of this case. Say triple product. I'm writing, say I have that 3 vector A, B and say C. So if I take A dot B cross C, first tell me, is it a vector or a scalar, this product?
Vector.
It's
Scalar.
It's a vector. Yeah, definitely is going to be scalar. Look at this. If you write, say that A dot B cross C, if you represent by a new vector, say that D, see, I replace that one, then definitely this is a scalar quantity. A dot D would be a scalar quantity, it's not a vector. So that's why we can write, if you write A dot B cross C equal to B dot A cross C equal to C dot A cross B. It will be the same. All the permutation combination would be over here same. Why? Because that is the reason I'm telling you that one. It will be the same quantity. Why? Say I have a vector like that. I represent these vectors, say that by 2 1, which is vector B, and this is the vector C. If I take the cross product of this B cross C, what it will give me, or what is the physical significance of this cross product? Can anyone tell me? Say I have a space, in that space I have this region, I represent one side of that space by a vector B and another side of a vector C. Then if I take the cross product B cross C, what it will give me? What the physical quantity I am going to find out of that one. So think about, in your room you have a floor. In that floor, if you express one length by a vector and another length by another vector, if you take the cross product of these two vector, then what it will give you?
So another vector product.
area.
It's the area. Yes, exactly. This will give you the area of that region. This is the area, right? So that means area is a vector. Remember that case. If you write, say that B cross C, that would be basically that area, which is a vector. And that's why when you write down the formula for the area, we write always length cross breadth. Length cross breadth.
And sir, in this case, what about the eta?
Eta, yeah, I'm going to say that. It would be always the perpendicular to that surface. If you take the B cross A, it would be towards that direction. But if you take that C cross B, that would be towards that negative below direction, actually over here. If you take the B cross C, it would be positive eta head. But if you take the C cross B, that's going to be the minus direction. Remember this point, area is a vector and that direction of the area would be always perpendicular that surface. It's a very useful concept. Now with that area, if I multiply another third component, say this is that A, what it will give me? Area into one more length.
Volume, I think.
It should be volume. Exactly, you were right. It's a volume. So that means if you multiply area with another dimension length, that will give you that volume of this region. And the volume would be the same for a particular object. Say if you have this case, this one, if you take that any combination of product, the volume of this object is going to remain same. It's not going to change, right? Volume is not going to change of this object, so that's why it will be the remain same of this dot product. A dot B, B cross C will be the remain same. It's going to represent that volume of this case. So that's why I write down this equation would be the equal of this triple product. But what about, say, if I take the cross product, because this is will be cross product, say that A cross B cross C is not going to be equal to, say, that B cross A cross C, or another combination. If you write not equal to, going to be the C cross A cross B, that's not going to be the equal because of that direction. Direction will be the different, right? Every case, these, if you change that one permutation combination of these three vectors, the direction of the resultant vector direction is going to be changed. If the direction is going to be changed, then definitely a vector is going to be changed, right? Either you change the magnitude or either you change the direction, or any one or both. If you change, the vector is definitely going to change. So that's why these are not equal. Then how we are going to find out this triple product of this vector product? If I write A cross B cross C, then we can write, actually this is B A dot C minus C into A dot B. This is a back cap rule, actually we define in physics. Actually say B, if I write down the letter only back, and this is actually cap, back cap rule. It's a back cap rule. We use that one, actually, back cap rule, and that's how actually we can find out the triple product. Or if it is more than that, actually, say I have 4 vector right now, C cross D, this one and this one, then I'll write E cross C cross D, right? Now this is actually the 3 vector. Now I can use the backup. Right now it's difficult, so that's why I write down another way. This one I write down in term of number. If I give the 1 2 3, this is actually that 2 1 3, and this is actually 3 1 2. Then I'll write down, look at this, 2 is over here. No, you don't have to memorize. I'm going to show you how you can write down that formula. So it would be C, because this is the 2, which is the C, 2 1 3 is a E dot D minus 3 1 2. 3 is actually the D, 1 is the E, 2 is the C. That's how actually you can find out that if the cross product, if there is more than 2 3 or 4 vector. Otherwise you have to take this one cross vector first, then this one cross vector first, then combine these two, one again you have to take that another cross product, which is a time consuming. But using that backup formula we can find out that more than 2 3 or 4 or 5 vector at a time in that way. But remember, using that one, we have to always write down in a form, say A cross B cross C in a that form. I cannot write, say, if my vector is that form, say if I write A cross B into C, I cannot use the backup rule over here. The backup rule, if you want to use, then I have to make this parenthesis, basically the second term. So in that case, if I write down minus C cross A cross B, then I can use my backup formula. This is my first vector, and this is actually in the parenthesis would be A cross B over here. Then we can use that, actually the backup formula. That's how actually we can use, take the cross product of more than 1, 2 or 3 vector. Alright, that's all for today. Please give your attendance within 1 minute. Just write down your ID only. Alright, thank you very much. If you don't have any question, guys, you can leave the meeting.